मेशिंग झालं होतं वेगळं आहे की रे आहे ना मला वाटलं तेच आहे तुझं काय नाही त्याला वेळ लागायला लागला चोवीस पार्ट आहेत 24 कॉन्फिगरेशन जर चांगलं असेल ना लॅपटॉपचं फास्ट होतं बरं का तिकडे आता एजिबल गणित सरांचा PC आहे 8 GB रॅम आहे त्याला प्रोसेसर आहे फास्ट होतं 8 GB रॅम आहे आता इथं मेसेज आला असा इथं मेशमध्ये मी काय करतो ॲडव्हान्स मध्ये मेश मार्किंग जे डिसेबल आहे ते इनेबल करतो ठीक आहे Now we will hide some faces for applying temperature, heat flow, hide face, hide face, hide face, hide body ठीक है now select inner surfaces just move the cursor this way heat in 100 degrees Celsius after this show all bodies now here on surface show hidden faces select all faces, all, because all are contact in here. ठीक है. Just move the cursor by clicking the control in this way. Insert convection. Convection will take 0.89, ambient temperature 35. Then we will apply heat flow rate from this inner surface. This surface. We'll apply heat flow rate. Insert heat flow. Direction also we can define, but here we will write directly 100 watt. Heat flow rate 100 watt. Direction we can give because heat flow is vector quantity. Then we will apply heat flow, radiation. Now radiation emissivity is equal to 1. It is applied. Now ambient temperature we will take 35 degrees Celsius. Okay. Then we will apply heat flux on this end. Insert heat flux. Heat flux we will take 12 watt per meter square. Now in analysis setting, the step end time we will take 2 seconds. Now auto time stepping is there, that we will keep off. Defined by substeps. The number of substeps 200. And step end time we will take 2 seconds. Now solve. Number of parameters are applied. It will take some time for analysis. Just see here. Now critical results I have got here. Around 200 answers with respect to time. You can see the table at the right side. And this is the temperature versus time graph. So temperature is changing with respect to time. You can see this graph. This is the temperature graph. And see this temperature variation animation with respect to time. So maximum temperature it is 2174.5 degrees Celsius. Now we will see total heat flux. So total heat flux we will see now, and results are also critical because 200 steps were given. We can give 1000 steps. No limit for us, 10,000 steps. So as we increase number of sub steps, we will get good results. We will get critical results, and that is expected. If we increase time of analysis, we will get accurate result. Now see total heat flux graph. So this is graph of total heat flux. Just see here. This is a graph of total heat flux with respect to time, and total heat flux is decreased with respect to time 2 seconds. So this is a response within 2 seconds. Are you getting? This is a response within 2 seconds. So within 2 seconds these are the changes. Now if we see thermal or directional heat flux, evaluate all results. It is taking more time for evaluating because it is a big problem. Now you can see this is a directional heat flux. Now directional heat flux is getting increased with respect to time. This is a tabular data to the right side. You can export this tabular data to MS Excel. Now we will see at a particular point we will see the temperature distribution. At particular point within 2 seconds temperature is getting changed at a particular point within 2 seconds. So the same procedure, we will select mesh, single select. I will select this node. You see this. Then create name selection. So TEMP1 I will give name. Then insert thermal temperature and geometry selection, name selection and TEMP1. Now you can see here at a particular point this is a temperature change. At a particular point this temperature is not constant. If you do steady state analysis, so temperature graph will be straight, but in transient analysis it is increasing with respect to time. At that point temperature is 22.279 maximum. You can see this is a graph at a particular point. Now we will see temperature at another point. So we will select point inside the pressure vessel. We will select point from inside the pressure vessel. So first of all we will hide some faces. Select geometry. We will hide some faces. Okay. Now we will select point inside the pressure vessel. To select mesh, so I will select this point, particular point I have selected. It is a element. Once again create name selection. So TEMP2 I will give name TEMP2. Then insert temperature, geometry selection, name selection, TEMP2 and evaluate all result. Now you can see this is a graph of temperature at that point, and the maximum temperature it is around 200 degrees Celsius. Here you can see around 200 degrees Celsius temperature is there inside. We had applied 1000 degrees Celsius temperature inside, but why this much change, why this much reduction? Because we have considered convection. So due to convection this is a happening. Then we will consider another point for getting temperature. Show all bodies. We will consider any a group of elements. Select mesh, box select. So we will select these nodes, are you getting these elements on the surface, then create name selection temp3. Now insert temperature, name selection, and temp3, evaluate all results. Now on this particular region, this is the temperature distribution, this is a graph, are you getting, temperature versus time. Similarly we can get a graph of heat flux on that region. So total heat flux, geometry selection, name selection, temp3. So on that particular region we will see heat flux. Now this is the distribution of heat flux and it is getting decreased with respect to time. Are you getting? So likewise you can do the analysis of pressure vessels. This is a thermal analysis of pressure vessel. It is a thermal analysis. Are you getting? So as you increase number of steps, you will get more results. Suppose you want temperature on particular surface. So I will select this surface. I will select this surface and insert temperature. Evaluate all result. So here you can see temperature distribution on that surface. You see the depression, variation, decreased, increased, decreased, because it is a spherical surface. Therefore it is happening. It is a spherical surface. Therefore temperature distribution is different. Now you try to solve this. It will give number of results as we want. Now you see here I will take static structural, transient thermal is done here. I will take static structural. Now same geometry we will take here. Okay, and model, it is there. You don't click on this model, just click on update project. Now once you click on update project, there will be a tick mark on model. Here there will be a tick mark. Automatically machine will be there. Next step is important. Now we are exporting thermal data to static structural data. Are you getting? And here we will apply pressure now inside the pressure vessel. Means the answers will be combined answer. Means temperature, pressure, heat flow rate, convection, all parameters are applied on that model. Are you getting? It is the meaning. Now it is updated. Now you see here setup question mark is there to the setup. So here solution is there. We have to export this solution. Just drag this solution to the setup. Drag solution to setup. Do not drag solution to solution. Huh? Drag solution to setup. घेतच नाही ते. Double click on setup and it will ask upstream data needs to be reread. Would you like to read the upstream data? So yes. Now it will start in static structural mode. Still it is importing the data. Import झालेलं नाही अजून. इथे एक मेसेज येतो इम्पोर्ट झाल्यावर. येस का मग इंग्लिश म्हणाले Now here you see there is a message. You can see imported load. When this message is appeared means your data is imported. Imported body temperatures. Are you getting? So from transient thermal analysis, temperatures are imported. Now we will apply pressure inside and we will fix the outer surface. For this purpose, hide body. Now it is appeared here. Now I will select inner surfaces all. Okay. Now we will apply pressure inside pressure. Then pressure value is 10 Pascal. Randomly I have written. It's okay. Then we will fix outer surfaces of the or displacement will be 0 on outer surface in z direction, in vertical direction. Okay. Insert displacement in z direction 0. Are you getting? Now you just click on solve. Vertical direction only. There is support from the bottom. Are you getting? But here support is not drawn. Okay. So all bodies. If support is there, you just fix the support. Here support is not there, therefore I have taken fix on outer surface. Now it is importing result initially. You see this message. First of all, it is importing. Now it is solving. Now the results you will get. These are the thermal stresses. Are you getting? You can call them as a residual stress also. Do you know residual stress? Now you see insert stresses. Now these stresses are thermal stresses. Are you getting? These are the thermal stresses. Are you getting? These are the thermal stresses. Let it be. No? Values we have taken randomly. These are not real values. Are you getting? So as it is, analysis is done in company. Thermal plus structural. This step is very important. This is coupled field analysis. आपण आता randomly केलेले आहे. Procedure is same. You can see maximum deformation. maximum shear. Now you see in company, see one of my friend he was asking to find out how to find out localized stresses near to nozzle. So here is the nozzle area. These openings are nozzle areas. Listen, these opening here nozzles are attached. Are you getting? So in this corner, localized stresses are occurring. Are you getting? Because here are chances of leakages. Therefore, localized stresses occur on this region. So you have to select this region for finding out localized stresses. Are you getting? So localized stresses we will find out this around this area. So we will select mesh and lasso select. We will select lasso. You select the region around this. This is very important. So localized stresses are occurred near to openings. It may be nozzle or you getting any opening will be there or any wall is there near to this localized stresses are occurring. So insert and one Mises stresses are obtained always. One Mises stress defines failure criteria. Are you getting? Just wait a minute. One Mises stress geometry name selection. So these are the one Mises stress 4.3. See one Mises stress what does it show? It shows failure criteria of your component. Your model can sustain 4.3 into 10 raised to 9 Pascal stress. This is meaning of one Mises stress. Your model can sustain this stress. It is giving one judgment. Are you getting? In this area, this stress can be sustained maximum. Are you getting? If stress goes beyond this failure, that is one Mises criteria of failure. Are you getting? One Mises stress means what? You are getting value of failure stress, capacity of your model. So all these stresses are not static stresses. These are not obtained from static structural. There is a data import from thermal analysis, and these are the thermal stresses. Are you getting? You solve this.